and that is this kid and what he represents. And it's been such a, I guess, privilege to have you here with us, and he gets to speak his second time during this conference. And thank you all for sticking around and being a part of this. And after he's done, we'll talk a little bit about next year briefly. Okay.
All right, well, thank you guys, but it's really been my privilege to be here, and I thank Carrie for everything she's done. She's just such a nice person, as nice off-air as she is on-air, which sometimes with meteorologists is not always the case. She's a very nice person. So I'm just waiting for my presentation to load. In the meantime, I'll tell you in advance that I did this presentation more just for fun, to give you guys a perspective about recent New England weather extremes, rather than having some sort of presentation about warnings or things like that. So I'm going to start right away. We have 3 different events I'm going to take a look at. For starters, we have the June 1st, 2011 tornado that hit western Massachusetts, and this is part of the worst tornado outbreak in southern New England since the infamous Worcester tornado of 1953. And I'll draw some comparisons between the two in just a moment. And we actually did have 3 deaths reported with over 200 injuries. Now, I decided to get rid of the February 8th storm. Nemo last year, even though there were 40+ inches of snow in Connecticut and there was thunder snow, and I love talking about thunder snow, I decided against doing that one because I was a little bit sick of winter. I also have a much more impressive winter storm. And why even bother talking about winter storms now when evidently it's all due to geoengineered snowstorms? So evidently we don't even need to talk about winter anymore. And last but not least, I'll talk about the December 9th, 2005 snowstorm. It's really the forgotten blizzard because so many of you have heard about the 2005 blizzard. And every single time someone hears about the 2005 blizzard, I think, oh yeah, the December 9th storm. And they say, December 9th? What are you talking about? Evidently there was some storm back in January that gets all the attention. But this really was the forgotten blizzard, referred often to as a snow cane because there were winter waterspouts, incredible thunder snow, and I'll get to more on that in just a few minutes. I decided to swap the February 8th and 9th storm out instead for a recent Aurora storm we had back in 2003, which was pretty much the most astounding of the solar cycle of the past 2 or 3 solar cycles, as a matter of fact. So just comparing the June 9th, 1953 tornado with the June 1st, 2011 tornado, there were some font issues. The 1953 one was an F5, but this particular one in 2011 was an EF3, had 160 mile an hour wind, so that's very close to the EF4 criteria. There were 46, the 1953 storm traveled 46 miles, and very similarly, the one in 2011 traveled 39 miles. 93 deaths in 1953 with over 53 million in damage. Convert that to today's dollars, and that's within the top 5 or 6 weather-related disasters in the United States. Whereas with this one, we had $0.2 billion in damage in 2011, and there were 3 deaths. Some people say 4 deaths, but I could only find 3 verifiable ones. So jumping right in on June 1st, 2011, we had 5 individual rounds of severe weather. So it was just one area getting hit time and time again. We actually had 6 tornadoes throughout New England, and this was all preceded by a tornado watch at around 1:40 in the afternoon with very high tornado probabilities for New England. So I'd like to show you just radar throughout the entire day. The day started off really warm and moist, but right around 9-10 a.m. we had a warm front move through the region and trigger a round of showers and thunderstorms, some of which were pretty severe up along Cape Ann. You can see the severe ones right there. I was right here at the time, and we had one storm interrupt our school day, and we had a fire drill that day, and we went outside, and I can really say the air almost felt like a tornado. I always thought that was a cliche, but I had never seen wind so strong when it was so warm out. Temperatures in my area were around 90 degrees, but it was so strong. Here's a supercell right there. You can see the hook echo on the tail end of that, and this particular storm started to hook out a little bit, actually produced a tornado in the Springfield State Forest. So we had 4 tornadoes across central Massachusetts that day. Giving you a better perspective on the supercell, take a look right here, and you can see that debris ball actually on the southwest side of it. And in fact, there was a second storm to the north of it that briefly came with the hook echo. And at one time, there were 6 different areas of circulation within this massive supercell thunderstorm. You can see one there, one there. So needless to say, a very impressive event by New England standards. So I want to compare this to the 1953 tornado because the similarities really are incredible. This is a picture of the 1953 tornado. This was looking out across Lake Quinsigamond, taken by the late Henry LaPrade. I hope I'm pronouncing that correctly. That was around 5 p.m. The funnel is 3 miles in the distance at this point and is about a mile wide. right here in this picture, you can see remarkable similarity between the two pictures. If I only colorized this one a little bit darker, black and white, maybe they would have looked almost identical. Yeah, had they been the same color, I would have thought they were the same tornado. This one's looking about 1.5 miles to 2 miles away, and this was when it was just over a half mile wide, taken around 5:15 p.m. in Monson, Massachusetts. And the aberrations on radar were both very similar. Take a look at the 1953 storm. This was taken by MIT's radar at around 5:09 p.m. in the afternoon. And the interesting part is that this was only the 4th hook echo ever observed on radar, the first one being back about 2 months prior to this in Illinois. There was actually a person from the Illinois Water Survey taking pictures of radar, trying to figure out how rainfall rates correlated to radar aberrations. And then, of course, you can see the debris ball that's as the storm was crossing the Springfield State Forest. The hook echoes were similar size. The one in 1953 was 6 miles in diameter, whereas this one was about 4 miles in diameter. So needless to say, a very impressive event. Here we go. This is the only picture of the 1953 storm. Tops are around 65,000 feet. In fact, it was visible about 105 miles away in Schenectady, New York, at the same time this photograph was taken. And people at the GE lab were making observations at the time, and they recorded this on a film strip over 10 minutes, and they recorded 6 to 10 individual towers making up this storm, and they said they were all rotating counterclockwise. So obviously, there's definitely some circulation in that, and of course there had to be if it produced an F5 tornado. Many people actually theorized that the tops could have been above 70,000 feet. I was a little conservative when I put 65,000 feet, and this one actually had tops over 60,000 feet. I'll show you the tops in just a second on the radar screen, and this is when it was about 50,000 feet tall. This is a similar supercell thunderstorm. I didn't find any pictures of the actual supercell thunderstorm that caused a tornado, just because that really spawned off of this supercell thunderstorm, and relatively quickly, as a matter of fact. So here you can see the tops. The southernmost storm, I'll show you again in just a second as it loops around again, but it's this southernmost storm right here that produces a tornado. The northern one prompted a tornado warning, and then this one produces 2 EF1s and an EF0. And the hail sizes obviously were very similar as well. And that was taken by Rita Canny back in 1953. That's a flash bulb for comparison, so this is about 3.5 inches in diameter. And this is the one that hit the Springfield State Forest. Hail was about 4 inches in diameter and actually set the Massachusetts state record. And earlier I was talking about that tornado watch with fairly high tornado probabilities. They're given a moderate chance of tornadoes, and the discussion actually mentioned supercells. This watch was followed up twice. This is the first one at 1 p.m. in the afternoon, and they mentioned large hail damage and winds and isolated tornadoes because of all the supercells, and 3,500 joules per kilogram, so obviously very unstable. I'll show you the soundings in just a second. And then 8 o'clock p.m., Plymouth County and the Cape were both added to the watch because there was a supercell developing over southeastern Connecticut and Rhode Island, and they continued that threat for tornadoes through 11 p.m. Here's a sounding from Albany, New York. You can see a little bit of a capping inversion right there. But the real thing I wanted to highlight, is right around here. 3,601 joules estimated per kilogram of Cape, which is just incredible for, eastern United States, or even the Northeast for that matter. Here's Chatham, Massachusetts, near where I live. And unfortunately, you can see how weak the sounding is. Look at all of Cape, 0, depressing. And here we go, that's just a comparison again between the stats. Quite a bit of wind shear. This is at the time that the tornado was on the ground, preceding the tornado a bit by maybe half hour at the most. And you can see there's quite a bit of speed shear, or more directional shear, I should say. Not as much speed shear, but definitely enough to produce that tornado. So here's 4:30 p.m. This is about 13 minutes after the tornado touched down. It was really just a jumper for the first couple of minutes. This is as it was over West Springfield, Massachusetts, and it was only an EF0 at this point. But this particular storm spawned off the other storms very quickly, and you can see a bit of a developing hook echo right there. But it's much more prominently visible when I show you the velocity right there. Winds at this time were about 80 miles an hour. This is a statement as of 4:26 p.m. 4:30 p.m. I can show you it was on 22 News Live, and it was actually on 3 different stations live. And you can see this is live speed. I'll speed it up in just a second. But you can see that rotation within the cloud. I had never seen a tornado actually captured live on the news in southern New England before, so this was just a monumental moment in New England severe weather forecasting and television meteorology. And I want to show you this video sped up a little bit because that's really cool. Take a look at this. You can see it right there, a few power flashes, and then it crosses the Connecticut River and becomes sort of hybrid supercell tornado waterspout, which was really cool. And then it moved off to the east over West Springfield. And at this point, again, winds were around 80 miles an hour. Here's a picture as it was crossing the river into Springfield from a different vantage point. The video's loading. Right around this time, unfortunately, one of the fatalities took place as a woman sought refuge in her car and a tree fell on it. And this was again when it was crossing Memorial Bridge. I'll just let the video play out for a second so you guys can get a chance to see. Very prominent supercell structure. You can see a great wall cloud here. And it's not often that you see structure that operate in Massachusetts. This is about 2 minutes after that video was taken and it's crossing the river. Here's a river right around here. It crossed that river into West Springfield and actually threatened the amusement park. The Six Flags is located in Agawam, Massachusetts, and there was a school group that day from Hanover, Massachusetts, attending the amusement park, and they heard about the severe thunderstorm warnings issued. So they hopped in the bus and decided to try to beat the storm. But unfortunately, they got caught in the traffic jam and ended up 100 yards away from the tornado as it crossed the interstate in front of them, Interstate 84, I think, including the Mass Pike as well. I would have loved to have been in that school bus. Here's a satellite picture. I couldn't find any great satellite pictures, but this one I find pretty interesting because you can see here's the overshooting top of that original supercell thunderstorm. And I mentioned how we had 5 rounds of severe weather that day, so you can see the secondary area of severe weather starting to develop off to the west. And again, here's just a wider picture of that. 4:31 p.m. was when things really became dangerous. There's an observation from law enforcement of a tornado reported in Westfield and Shaker Road area. There was massive damage in the Shaker Road area. Here's that picture of the velocity at that time. You can see the hook echo becoming even more prominent and even more well resolved. Quite a bit of wind shear there. And then there's a secondary circulation starting off to the north. At this point, winds were 90 miles an hour. It was an EF1, and that's right as it crossed Memorial Bridge. For sake of time, I'm only going to show you guys a little bit of this video because it gets repetitive. The majority of the videos that are visible online and that you can find online of the Springfield tornado, I don't think are really give an accurate representation of its true strength, because by the time it was a half-mile wide, that was when it was over the Springfield State Forest, which is a much less populated area, much less densely populated, so there weren't as many videos evident. Very large hail associated with the storm. This is where the hail got about baseball size, and I showed you that picture earlier of softball size hail. That's 4:42 p.m. Winds were 110 miles an hour. Things were really starting to crank up. 4:55 p.m. they were tracking an extremely dangerous tornado. They said it's located near Palmer, and they actually provided evidence of observation. And in fact, the shear was getting so strong that it even disturbed the radar at that point a little bit. Oh, I'm sorry. Shouldn't advance the slide. Right here, as I was mentioning, that very strong hail, you can see right there a little bit of a hail spike on the radar. And in the next picture, this is really cool. You can see even a little bit of three-field debris scattering coincident with the hail spike, which I just thought was really cool. This is as it was crossing Springfield, EF2. I spoke to the National Weather Service. They said they actually, retrospectively, would have probably considered a tornado emergency for the Springfield area just because there was complete destruction. And I'll show you more pictures of the destruction in a moment. It's around 4:55 p.m. You can see the debris ball. This is my favorite video of the storm because this is over Munson. This is when winds were about 140 miles an hour. It was strengthening at this point as it was going downsloping a little bit. And the video, here we go. Yep, it's moving right towards the camera, moving due east at this point at about 40 miles an hour. This is the time that the debris ball really became evident, and it was about a half-mile wide at this point. Winds about 2 or 3 minutes after this video was taken exceeded about 155 to 160 miles an hour. So obviously an impressive storm. Across the southern end of Springfield, especially the Springfield State Forest, which is where the worst destruction occurred, as well as Sturbridge. And then later on we had a secondary supercell come along and produce that tornado that only lasted 3 minutes. And here's that debris ball again. It said at 5:09 p.m. This is an extremely dangerous tornado with a history of major damage in the Springfield area. And for sake of time, I'll just show you this. This is 5:36 p.m. The tornado left the ground at 5:27 p.m. And you can see that hook echo becoming really disorganized. Whereas the secondary storm starts to develop. And around that same time, this picture was taken of the decaying thunderstorms, although it did provide quite a light show for people in Boston. Quite a few animal crawlers as well. So there were over 200 reports of severe weather associated with this outbreak in southern New England. And with those reports, we had several, 5 or 6, of large hail, excessively large hail. This is in Munson. This is actually on Washington Street in Munson. That was Senator John Kerry surveying the damage. Here's another picture from a different vantage point of Washington Street in Munson. This is Bethany Road in Munson, and that's where some of the worst damage occurred. And you can see, here's the foundation. That's all that's left of the house. and we'll investigate a little bit more on the tree damage in just a second. This is basically what my school's internet looks like. I was telling someone earlier about how they bought 2 modems and instead bought 8 boosters to try to get internet across the entire school. You can see some great tree damage with this one. And in fact, I thought it was interesting how the National Weather Service assigns ratings based on tree damage. These different degrees of damage, 1 through 5, are not coincident with the EF scale, but we did definitely see trees uprooted as well as some debarked, only the stubs of the largest branches remaining. You can see that right here. Didn't see as many snapped, although perhaps a few right here. So definitely within the 3 to 5 range. And when we take a look at the graph, the 3 to 5 range puts us on average between 100 and 140 miles an hour with winds up to about 164 miles an hour for that 5 degree of damage of 5 range. And this is assuming the trees are hardwood, which many of the trees in the Springfield State Forest are. Here's Dave Bell's one-stop towing in Springfield, and that's where about 2 more fatalities occurred. This is a picture from NASA released about 2 or 3 days later, and you can see just the ground scarring associated with that storm. I want to take a closer look, I want to take a closer look right around here, because I got a better look from one of the local news helicopters, and you can see just how intense that tornado was, and how wide it was as it moved through the mountains there. This is actually not a trailer park, but a campsite, and the fatality occurred right around here. I had the opportunity to go out there, and as a matter of fact, the owner of the campground, individually, when he heard about the tornado, went around to every single trailer, banged on the doors, and tried to get people into the shelter. Everybody obliged except the one woman who was in a trailer here, figured that the best place of refuge would be enshrouded in sheet metal, and unfortunately she was thrown into the lake and did not survive, and that's just another picture from a different vantage point as well. Here's that last picture from Bethany Road. So I want to focus on the December 9th, 2005 storm, which is the Forgotten Blizzard, and I absolutely love this storm because I was in 3rd grade at the time, and unfortunately I don't remember a lot of it, but I do remember the principal coming over the PA system at around 1:40 p.m. when things really got bad and said that they would be sending everyone home early. But unfortunately the buses couldn't make it, so I was in gym class at the time when the power went out about 5 or 10 minutes later. And because it's an old building, there weren't any emergency lights or anything like that. So we were completely in the dark. We had to find our way to the nearest door, and we ended up going to the cafeteria. We had those really large picture windows. But we only lasted about 10 or 20 minutes in the cafeteria because the winds became so strong that for fear that the windows would break, they actually moved us back into the gym and opened up 2 of the doors to the outside. And about every 5 or 10 minutes you would hear a huge crash. None of us knew what it was, but retrospectively it was the thunder associated with the storm. It really was the snow cane. Basically, keeping things simple, outside of this line, or rather inside of this line, basically inside of Route 495, there was all the wind, not much snow, only 2 inches of snow down in Sandwich, but I don't want to belittle the storm because it was an insane wind maker. I'll show you some of the measurements in a second. Outside of here we had 6 to 12 inches of snow with a little swath of about 16 to 18 there. And the winds with this storm were incredible. We had 5 inch per hour snowfall rates, and some places picked up over 18 inches in 6 hours. Winter waterspouts developed in the warm sector, some of which moved ashore. I've never seen that before or heard of that, and I'll show you. I don't have pictures of that, but I do have a map of that a little bit later. A plane was struck by lightning at Boston's Logan Airport around 2:15 p.m. during landing, and it was such a vomitive storm that it dropped 17 millibars within 3 hours between 1 and 4 p.m. And for that reason, the wind gusts were insane, but the wind gusts really picked up as the storm was departing. So as the comet had started to develop and the wind shifted to the northwest, that's when we had the strongest winds. In fact, 105 miles an hour at Block Island. We had several 100 mile an hour readings, and 88 in my neighborhood. And I remember being sent to the basement because the winds were so strong. That's just one of a myriad of different wind measurements. I couldn't find any good satellite data, so I'm going to try to skip these as much as possible. Needless to say, you can see quite a bit of convection moving out over the ocean, and towards the last few satellite images, you can see that comet head starting to develop over the northeastern United States, particularly around Cape Cod. I'm going to show you the water vapor imagery, the reverse water vapor imagery, I should say. Here's that convection, and here's the comet head developing over the Cape and the Islands. So I want to go a little bit more into detail about this 2 p.m. lightning strike at Logan Airport, because there was an airport weather warning issued for heavy snow and strong winds through about 5 p.m. That came around 2 p.m. But they also mentioned the possibility of lightning. Now, it was Comair Flight 5437 that was forced to make an emergency landing at Boston's Logan Airport. Fortunately, it was going to Boston's Logan Airport. It was a flight from Baltimore to Boston. 35 passengers, 3 on crew, and it actually blew the left wingtip off. And many people refer to it as a lovely flight prior to that lightning strike. They said there was a ball of almost a plasma-like substance that was orange that suddenly entered the cockpit, accompanied by a very, very loud noise. I want to go into more detail about that because when I backed it up and found the radar image of that, it was really interesting because that was coincident. Reflectivity around here, I measured, was around 45 to even 55 decibels of some very heavy wet snow because the coastal front was battling those northwesterly winds. In fact, outside of this line right around here, it was still all rain. So very, very heavy snowfall in that area, and that's the area of thundersnow. There was actually a special statement issued for some very strong thunderstorms moving through the region from west to east. And in fact, this storm became so strong that I developed right here on the satellite imagery. I was searching for that satellite imagery and I just could not find it for the life of me. But I really wanted to show you guys that because it was so cool. In fact, there was a woman over Truro right there who reported around 3 or 4 p.m. in the afternoon that the winds really abated, everything became calm, she could see the sky, and within about 20 or 30 minutes things picked up again, which is why I refer to it as a snow king. So rather than going on about Nemo, the blizzard Nemo 2 years ago, I wanted to focus on the solar storms of November 2003 because these were some of the most paramount, incredible solar storms we've had in the past 2 solar cycles. So I don't know how much of a background you guys have in space weather, but basically we have what's called the KP index, and I'll get to that in just a moment. But the KP index measures the degree of fluctuation in the upper levels of the atmosphere caused by geomagnetic unrest. And in a given month, we'd expect to see KP indices maybe reaching 4 or 5 very briefly. That's what these are. Perhaps even a 6. When you have KP index of 6, you can see the aurora down through southern Canada, Alberta, or Alberta, I don't know how to pronounce it, Quebec, and perhaps even Maine and Michigan as well. But I want to show you a month later because this is early October of 2003 rather. And the sunspot that produced all this chaos and geomagnetic unrest came around on the 23rd, and that's when things really picked up. In fact, you can see KP indices of 9, which brought the aurora all the way down to parts of Louisiana, Florida, Texas, and even Mexico. So it was an incredible storm, and this lasted through November, the early half of November, because KP indices reached 8 again. So I'm going to give you guys a little bit of a background on the KP index, which I'll do evidently in just a second. I must have misordered the slides. Right here you can see this was on the second peak of the solar cycle as the cycle was winding down a little bit. So we had KP indices of 9, and the KP index measures the maximum fluctuation in degree of just a unit R. And it's a logarithmic scale, much like the Richter scale. So each increase of 1 on the KP index scale denotes a 10-fold increase in the fluctuations in the upper levels of the atmosphere in the geomagnetosphere. And it's normalized based on location. So say, for example, you're in Honolulu, Hawaii. KP index of 9 would be achieved through a fluctuation of only 300 R, whereas up in Alaska might require, for example, 1500 R. So that shows how throughout the Earth you can have numerous different instruments measuring the same thing and trying to get the same KP index rather than having it based on latitude. And higher geomagnetic latitudes require greater fluctuations to achieve certain KP indices because it's normalized. Again, as I mentioned, here's a chart. It's a little bit difficult to see, but everybody's latitude in terms of the geomagnetic scale, everybody's geomagnetic latitude is slightly different than their actual latitude because the North Pole is slightly off from the geomagnetic North Pole. So the geomagnetic North Pole might be right around here, and it moves about 6 or 7 miles every year due to that shifting Earth core versus the North Pole being right around here. So that's why it might be easier for, say, example, Nashville to see the aurora borealis, which is right here, towards that dip in the KP line contour right there, versus southern Oregon. So with the KP index of 9, we had the aurora stretching all the way down to parts of northern Texas. Even Mexico reported seeing the aurora borealis with this storm. So it probably went over 9, but unfortunately the scale only goes up to 9. Now, when we talk about aurora storms, we're always talking about the radio impacts as well, and it really only affects radio frequencies between 3 and 30 megahertz. But that's just enough to get those GPSs on airplanes in a void of radar. Because when they're crossing the Atlantic Ocean, there's no radar there, and they have to rely completely on short-range radio. And unfortunately, they can lose that radio reception within 1 to 2 minutes when those high-energy protons and high-energy particles impact the Earth. So I want to give you a little perspective on this October 28th and 29th solar storm. The trouble really began, as I mentioned previously, a week before, on the 23rd of October, and it was from sunspot 486. That sunspot actually became the largest in 13 years, and within the course of only 2 weeks, so 14 days, it produced 11 X-class solar flares, which is pretty much unprecedented. That was in fact more solar flares, more X-class solar flares than have been produced throughout the entire past year. And it unleashed a massive X-17 solar flare, which is actually the third largest solar flare on record ever, and an associated coronal mass ejection on the 28th of October at 11 o'clock Universal Time. And again, on the 4th of November, it produced X-28 solar flare, but unfortunately, well, fortunately I guess for the Earth, but unfortunately for solar flare lovers and aurora lovers, that was facing the wrong way to receive a glancing blow from the aurora borealis. Now, what's interesting is the fact that this solar flare, the energy associated with it that caused geomagnetic unrest in the aurora borealis, reached Earth within 24 hours, and normally we would expect it to take around 60 hours. So that just shows how quick this energy was moving. And the high energy particles reached the Earth near the speed of light, so within about 8 or 10 minutes, whereas, like I said, the other ones that caused the aurora borealis travel around only in quotes, of course, 5 million miles per hour, reaching the Earth at 6:12 Universal Time on October 29th. I want to show you a picture of that sunspot. This is sunspot 486 crossing the western limb. This is back in September of 2003. Didn't really emerge onto the most prominent part of the solar disk until October 23rd. Here's a video of that coronal mass ejection right there and the associated solar flare with it. And here we go. So you can see these high energy particles really affecting the SOHO observatory where the shot was taken. And you can see just how quickly it traveled. That's the solar flare right there. But within perhaps 8 to 10 minutes, that's when those high energy particles affected the viewing platform. And that's why the Space Weather Prediction Center in Boulder, Colorado has to constantly be watching the magnetogram, because like I said, within 8 to 10 minutes you can have a complete radio blackout on airplanes. So that's why they have to warn so quickly. And right again, here's sunspot 486, that's 484. 484 looks more powerful, but believe it or not, the more diffuse solar flares actually have more complex magnetic fields that are sometimes known to be more productive in terms of solar flares and coronal mass ejections. Now, the National Weather Service in Midland, Texas was actually one of the few that issued a public information statement mentioning the possibility of a powerful solar flare. This was around 6 or 7 hours after the original solar flare took place. And I want to show you a picture from Midland, Texas, because about 18 to 20 hours later, around 8:40 and 9:05 Universal Time, this is Midland, Texas, you can see just how prominent the aurora borealis was. And in Oklahoma, it actually reached 15 to 20 degrees above the horizon. And I want to show you a few more pictures. This one is from Albany, Missouri. Here's one from West Virginia, and I want to show you one from Dover, Oklahoma. This is the same place where in that area was reported, and you can see the aurora 15 to 20 degrees above the horizon. And I also want to show you a satellite image on the 30th of October. This is about 15 to 20 hours after those shots were taken. You can see the aurora storm retreating back to the north. So hopefully you guys enjoyed that. I had to include this slide on the request of my math teacher. It's a really interesting point that he brought up. Has nothing to do with recent New England weather extremes, but oftentimes people include the probability of precipitation. Which that's supposed to say 20%, I don't know why. I think I switched these. This should be 20%. So we expect a 20% chance of precipitation according to the Weather Channel. Yet we go into the hourly and we can see for all these different hours here, there's a 20% chance of precipitation within that hour. But what that mean would be a binomial distribution, yielding really a 73.78% chance of precipitation. I just had to share that. My math teacher brought that up, and I thought it was really cool. So with that, I have so many people I'd really like to thank. Of course, the American Meteorological Society for giving me this opportunity here today. I've had a great time going to these AMS conferences over the past 3 years. It's been great getting to know everybody here. I want to thank you all for welcoming me here and for being so kind to me and for everything you've done. Of course, Carrie and the program chairs for organizing such a great conference in such a beautiful part of the country. I've never been west of Nashville since I went to last year's conference, but it's incredible out here. I'm so sad that I have to go home tomorrow. I'd also like to thank Harvey Leonard. Yesterday, Mike Mogul mentioned that having a TV meteorologist welcome someone into their station really meant the world to those children. And it really meant so much to me getting to go to Channel 5 and see what they do behind the scenes. And I also need to thank the Kirk Gieser Foundation. I received a $2,100 grant a couple weeks ago that completely funded my trip out here and my conference fees and everything. And I need to thank the Kirk Gieser Foundation because what they do to inspire achievement and inspire educational pursuit in children is absolutely unbelievable. They have a great initiative, and I hope to work with the Kurt Gieser Foundation in the coming weeks and the coming months to help promote and advance that initiative. I'm so thankful to the foundation for everything they've done and for giving me this opportunity. In addition to that, they also provided funds to help me purchase advanced photographic equipment so I can continue my research on alpha boundary-related water spouts, as well as basically storms in general along eastern Massachusetts. The only problem is they couldn't provide any storms, so we've really been on a storm drought in eastern Massachusetts. But I need to thank the Kurt Gieser Foundation for everything they've done for me. I really appreciate it. Thank you, guys. Oh, questions? Yes.
Matthew, thank you for fantastic three talks in one. I was lucky enough to see an aurora from the storm about 10 years ago, so it was really, that was from Boulder County, Colorado. One of the only 2 times I've ever seen an aurora. I just wanted to follow up by pointing out that the highest risk of major solar flares is actually on the declining phase of the solar cycle. It's counterintuitive. You would think it would be when the solar max is peaking. It's actually on the downward swing, and we're now coming up on what looks like will be the downward swing of the current cycle. So it's something to keep in mind. If you want to learn a little more about this, I did an Atmos News post at the very end of April, 1st of May, about this kind of counterintuitive thing. And you can see let's see, this is, so the event was, in fact, on the downward leg of the last cycle.
Yep.
So, yeah, the next couple of years may be a good time for aurora watching.
Hopefully so. Any other questions? All right, thanks, guys.
Okay, we made it. We made it to the end. Huzzah! So everyone's been asking, and I'm sure some of you already know, we're moving back east next year.